Hello students, welcome to the KSMP Academy. We are starting the classes for physics for 11th and 12th, and we are taking according to CBSE board and ICSE board the syllabus, and in this video we are starting with the units and measurements. Now question is why units are required. So students, every physical quantity, maybe length, mass, time, force, current, etc., these are required to be expressed meaningfully, and this meaningful expression is done through numbers and units. For example, you see here length is measured if in 10 meters, then it is having two parts. One is 10, another is meters. So here number 10 is the numeric value and the unit of the length is meters. So to express the meaningfully length, we require two things, that is numeric value 10 and its unit meters. So that's why we are getting the expression as 10 meters. Therefore, for the meaningful presentation, both numbers and units are necessary. We have to remember it. Without it, a physical quantity cannot be expressed in a meaningful way. Other examples for we can take like that of force. So here value is 100 newtons. So here 100 is the numerical value and newtons are the units. Similarly for acceleration, 10 meter per second square. So 10 is the numerical value and unit is meter per second square. For current, it is 15 numerical value and ampere is the unit. So therefore, again we are repeating that to have the meaningful expression of a physical quantity, numerical value and its units are required. Now measurement. So measurement is very important in the scientific community. It is basically a process of comparison, and for comparison what we need a standard unit. You see, we need a standard unit, and this standard should be very well defined and it should be worldwide acceptable. So internationally accepted standard of measurement are known as units. So whatever standards are accepted internationally, these are known as the unit of that particular physical quantity. Let us see, for example, we are having a physical quantity P and it is expressed as Nu. So here N is what? N is the numeric value, and what is U? U is the unit. So let us say we are having a measurement as 10 meter. So here value of N is 10 and unit is meter. So what we are getting here, that in the measurement unit U is repeated n number of times in the measurement. So we can extend this example to every measurement. For example, if a measurement is 10 kg, that means 1 kg has been repeated 10 times. That is unit of the mass, which is kg. It is repeated 10 times, giving us the final result as 10 kg. So that's how we express the physical quantities. And for the standard, internationally accepted standards are there, that is of mass, length or any other quantity, maybe time. So these are very well defined and everybody is following that convention. So that's how measurement is very important. Now types of units. There are two types of units. One is fundamental, another is derived units. So fundamental units are what? Basically these are basic independent units. And these are defined by the international system of units, we say is SI units, and these units cannot be derived from others. However, other units may be derived from these. For example, if you look at here, the length, mass and time, these are the basic fundamental quantities and their units are the fundamental units. For example, for length if we have meter, for mass we have kg, for time we have second. So these are fundamental units or basic units. So in mechanics we can represent different quantities in terms of length, mass and time. So these fundamental units represents what? The basic scientific notions, and all other physical quantities can be obtained from these units. So we have to remember that there are two kind of units. One is fundamental, other is derived. Derived units can be derived from the basic units or fundamental units. Now let us look at the derived units. So as we are already discussing that derived units can be obtained through the fundamental units. So for example, you see here some of the units are written, that is for area, for volume, for density, acceleration, speed, etc. So as you can see that derived units are having multiplication or division of the powers of fundamental units. So that means it is clear that derived units are being obtained by the fundamental units. So look at here, unit of area is meter square. So meter is the fundamental unit and we are having power 2. So it is a derived unit. Similarly for volume we are having meter cube. So meter is fundamental unit. Similarly in density, kg is fundamental unit and meter is fundamental unit. So on. We have some examples. I hope it's clear that what is the meaning of fundamental and derived units. So thank you very much. I hope it is clear to you all that what is measurement and why it is required, why units are required, and what is the difference between fundamental and derived units and how derived units can be obtained. So thank you for being with us. Thank you very much.